Hello everyone, this is Mrs. Shaw, and today we are going to talk about sequences, arithmetic and geometric sequences. And we're going to look at this sequence and determine whether this sequence here, -5, -7, -9, and so forth, is arithmetic or geometric. So there's big hints here on the slide we have here. If we look at the recursive function, and we know in the recursive function, we're going to state what our first term is, which our first term in this sequence is -5. But also this recursive function already here, since it's written out for us, it shows plus. That gives us a big hint over that if we're adding something every time, that's an arithmetic sequence. The other big hint over here on the explicit function is we had here that it's looking for our constant difference and we're adding our 0th number. Those give us big hints that this is an arithmetic sequence. And if we didn't have this recursive function and explicit function written out here for us, we could still determine, we need to know how to determine if it's arithmetic or geometric by determining if we are adding something each time from one term to the next, or are we multiplying something every time? Okay, well, this one we can tell that we are adding -2 every time, but say you couldn't tell. So we would take any number in the sequence, say this -9, and we're going to say, let's check if this is arithmetic. So if we're going to take any term in the sequence and subtract the number before it. So we're going to have -9 subtract -7, okay, which is subtracting is the same as adding that +7. So we'll have -9 plus 7 gives us -2. And our constant difference in this sequence is -2. Well, we need to double check that. Are we adding -2? -9 plus -2 gives us -11. Yes. Plus -2 gives us -13. Yes, it does. So in a recursive function, we need to always state what the first term in the sequence is, and then we need to state our f of x equals f of x minus 1 plus our constant difference there. For the explicit function, we need to have the constant difference, which we determined was -2, times x plus our 0th number. We haven't determined our 0th number yet. The 0th number is the number out here in front of this first term, which is -5. So if in the sequence we are adding -2 each time in the sequence, to work backwards, we would do the opposite and add the +2. Well, -5 plus 2 is -3. So our 0th number is -3. What this explicit function is great for doing is to find any term in the sequence. I am going to now, we're looking for the 8th term in the sequence, the 8th number in the sequence. So that means with this explicit, we put our 8 right in here to this x, right in this explicit function. And we will have our -2 times 8 plus -3 or -3. -2, see if this will look, there we go. -2 times 8 is -16 plus -3 equals -19. So we know the 8th term in this sequence is -19. All right, moving on. Here is another sequence, 6, -66, +726, and so forth. There's some big hints here as well to determine whether it's a arithmetic or a geometric sequence. If we look here at this recursive function and we see that our first term in the sequence we see is 6, and then it's stating here our f of x equals f of x minus 1 times. We know if we're going to multiply that we're going to have a geometric sequence. The other big hint over here on the explicit function is with our geometric sequence, we take our 0th number and we multiply that by our constant ratio to the x power. So we have a geometric sequence here. So this one is geometric. if we didn't have these functions written down here and we only had the numbers up above, we can tell, looking at it, are we adding something every time? Well, let's see. If we take negative 66 and subtract 6, like we did on the last slide, we end up negative 66 minus 6 gives us negative 72. So is negative 72 our constant difference? Are we adding negative 72 each time? Well, that's not going to give us positive 726. So we can tell this is not an arithmetic sequence. We already did determine it was geometric, so we want to figure out what the constant ratio is. So we are going to take any number in the sequence and divide the number before. So let's take 726 and divide negative 66. Or you could have taken negative 66, which one is a little easier to do in our head, and divide 6. And you will get negative 11. So our constant ratio is negative 11, which means we are multiplying each number by negative 11, and we need to double check that. So we can check, are we correct with this constant ratio? Is 66 times negative 11, is 6 times negative 11 negative 66? Yes. Is negative 66 times negative 11 positive 726? Plug it in your calculator. Negative times a negative is a positive, and negative 66 times negative 11 is positive 726. And then 726 times negative 11 gives us negative 7,986. So yes, negative 11 is our constant ratio. So we need to remember in our explicit function, our constant ratio is the number that has the exponent of x. So we still need to figure out our 0th number. Our 0th number, of course, over here is the number before the first number. If we are timesing by negative 11 going this way, we need to divide by negative 11 to go backwards. So we will have our 0th number is going to be negative 6 over 11, or since we are dividing by a negative. So our 0th number is negative 6/11. All right, we need to find the 8th term in this sequence. So something we need to be very, very careful with when we are typing this in the calculator. We have a negative number with the exponent x. Please make sure you use parentheses on that. The calculator will want to just take 11 to the exponent of x instead of the negative as well. Please use your parentheses on that. And let's type that in our calculator. Pull out your calculator. We're going to type in negative 6/11. And we're going to times that by, and we're going to use our parentheses, negative 11. And we're going to raise that to the 8th power because we want to see the 8th number in the sequence. And I got here negative, it's a big number, big negative number, negative 11 or 116923026. So definitely love our calculators on these explicit functions of geometric sequences when we figure out our different terms. So that was the 8th term in the sequence. All right, next slide here. Okay, here we are given the recursive function, and we need to determine what the sequence is and if it's arithmetic or geometric. And then what the explicit function is. All right, we've got a lot to figure out here. Well, some big hints here for if this is geometric or arithmetic is right here in this recursive function, what they gave us. We have our first term is 3, so we know we can write 3 for our first term. but then we're multiplying by 1/3. If we're multiplying by 1/3, we know that that would be a constant ratio, and this is going to be a geometric. And we are going to multiply by 1/3. So we can go ahead and list what our numbers in this sequence are. So 3 times 1/3 is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. And 1/9 times 1/3 is 1/27. Okay, so there's our numbers in our sequence, and they would continue on. And we also need to write down what our explicit function is. Remember, an explicit function in a geometric sequence is we need the 0th number multiplied by our constant. So here's our 0th number multiplied by our constant ratio to the x power. So let's fill these numbers in. I'll change colors here. Our constant ratio, we already got that from this recursive function. Our constant ratio is 1/3. What is our 0th number? Well, our 0th number, we come up here. So if we are multiplying going this way, if we're multiplying by 1/3, then to get this number out in front of this number, we need to do the opposite and divide by 1/3. So what is 3 divided by 1/3? I'm going to write it down here. Remember, when we divide with fractions, that's the same as multiplying by the reciprocal. The reciprocal of 1/3 is the 3/1. And so dividing by 1/3 is actually the same as multiplying by 3, which would give us 9. And we can double check this. If our constant ratio is 1/3, that means is 9 times 1/3 3? Yes, it is. And we could double check that all the way through. Let's go ahead and figure out what the 7th number in this sequence is. So we want to figure out what f of 7 is. Well, first of all, we need to finish our explicit function. I forgot we didn't finish that yet. We need to write down our 0th number right here, which is 9. Okay, so our 7th number means we're going to plug in 7 right into our x up here. And we're going to use our calculators. And remember, when your constant ratio is a fraction or a negative number, you need to use parentheses in there. So pull out your calculator and type 9 times 1/3 to we want the 7th power, because we're looking for the 7th number. And we get a decimal that we change with math enter. You can change that to a fraction, and our fraction is 1/243. All right, that was a great example where they gave us the recursive function, and we had to find out what the sequence was. Another one here. They're giving us here the explicit function, and we need to figure out what the sequence is. Well, let's even just determine if it's arithmetic or geometric. Right here, they gave us this plus. This is a plus here. We have with the plus sign, we know that this is our constant difference times x plus our 0th number. And this matches with an arithmetic sequence. So arithmetic. All right. So with an arithmetic sequence, we still need to determine what the sequence is. Well, our constant difference is -4. Oh, let's write the recursive function. Part of the recursive function. Oh, we need to determine what the first term is. Well, our 0th term is 7. Okay. So our term out here out front is 7, I should say. And our constant difference, what are we doing every time going in this direction? We are subtracting 4 every time. -4 is our constant difference. 7 minus 4 is 3. 3 minus 4 is -1. -1 minus 4 is -5. Negative 5 minus 4 is negative 9, and negative 9 minus 4 is negative 13. So we have filled in our sequence up here. We can also write our recursive function now. We know what the first term is 3, and then we know for any term in the sequence, we take the term before it, we subtract 4 every time. Oh, now we need to find out what the 10th number in the sequence is. The 10th number, that means we want our 10th number. We are going to plug a 10 into our x right here, and we're going to have negative 4 times, so maybe if I change colors, that will help here, 10 plus 7. So our 10th term in the sequence is going to be, let me expand this page a bit. All right, maybe keep my colors changed so we can see it better. Negative 4 times 10 is negative 40, plus 7, we're going to have negative 33. Will be our 10th number in that sequence. So I hope this helps everybody on their assignment today, and let's keep practicing with these arithmetic and geometric sequences.